right, lesson 30. It's our second lesson about special lines and triangles. We're going to introduce a new vocabulary word and a new concept today. If you remember, yesterday we did mid-segments. Okay, so let's review that a little bit first. In triangle ABC to the right, D is the midpoint of AB, E is the midpoint of BC, and F is the midpoint of AC. Complete each statement below. Segment DE, see if I can draw it, is parallel to segment AC and measures half the length of AC. Okay, DF is parallel to BC and measures half the length of BC. EF is parallel to AB and is half the length of AB. Okay, that's our little review on, we just drew 3 mid-segments. And as a review, they're parallel and they're half the length. Okay, let's talk through this. In the previous 2 lessons, we proved that A, the midsegment of a triangle, is parallel to the third side and half the length of the third side. We also learned that diagonals of a parallelogram bisect each other. We use both of these facts to prove the following assertion. First of all medians of a triangle are concurrent. What does concurrent mean, you ask? Well, 3 medians of a triangle, the segments connecting each vertex to the midpoint of the opposite side, meet at a single point. That's what concurrent means, that they meet at a certain point. So we have the word concurrent and meets at a single point. This point of concurrency is called the centroid. So other things we need to know. Point of concurrency is called the centroid, or the center of gravity of the triangle. The proof also shows that a length relationship for each median. The length of the vertex to the centroid is twice the length from the centroid to the midpoint of the side. So let's look at this right here. Median. A median is a line drawn from the vertex to the midpoint of the opposite side. This is the midpoint because these 2 segments are equal. Vertex to midpoint, these segments are equal. Vertex to the midpoint, these 2 segments are equal. So this dot right here is called the centroid, which is also the center of gravity. That means that if I cut this triangle out and placed it on the tip of my pencil right here, it would balance perfectly. Okay? This proof is also going to show that the length from the vertex to the centroid is twice the distance from the centroid to the midpoint. So the length here is twice of this length. Twice of that length and twice of this length. In essence, that means that each median is cut into 3 equal pieces. So 1, 2, 3. Yeah, I guess I could use dots. So the distance from each dot, those are all equal. Okay, 3 equal pieces. Example 1. Provide a valid reason for each step in the proof below. Aren't these proofs the best? They walk it through for us. Given triangle ABC with D, E, and F as the midpoints of the sides, prove the 3 medians of triangle ABC meet at a single point. So we're proving that they meet at a single point. Median, median. Of course, we didn't do this median right there. A, B, C, yep. First, draw midsegment DE, done. Draw AC and DC, label their intersection at point G. So we drew midsegments. Goodness. Draw midsegment DE, and then draw AE, there we go, and CD, and label their intersection as point D. So we have a median, and a midsegment. And the two medians intersect here. Construct and label the midpoint AG as point H and midpoint of GC as point J. So we have the midpoint of AG. There's the midpoint of AG and the midpoint of GC right there. So that's the middle of this segment and the middle of this segment. So first of all, DE parallel to AC. Segment DE is parallel to segment AC. DE is the midsegment of triangle ABC. So we have definition of midsegment. That makes sense. Next, let's look at, HJ is parallel to AC. HJ is parallel to AC. If I look at this triangle right here, HJ is the midsegment of triangle AGC. So this is parallel to that. Okay, I know it's the midsegment because it's constructed from the midpoints that we constructed. And then DE is parallel to HJ. We've already said DE is parallel to AC, and then we said HJ is parallel to HC. Therefore, DE is also parallel to HJ. If two lines are parallel to another line, then they all are parallel. Now we have DE is half the length of AC, and HJ is half the length of AC. Definition of a midsegment. Okay, I drew them with red. So now we know that DEJH is a parallelogram because we've already said that these opposite sides are congruent and they're parallel. Okay, that's enough. That's all we need to say for this to be a parallelogram. One pair of opposite sides being congruent and parallel says it's a parallelogram. Now let's get into this right here. All of these pieces being equal. Okay, these right here are our diagonals. HG is equal to EGE and JG is equal to DG. These are diagonals that bisect each other in a parallelogram. So when you have diagonals of a parallelogram, they bisect each other. So this piece is congruent to that piece, this piece is equal to that piece. Definition of parallelogram, diagonals bisect each other. Okay, that was for number 8. Let's go over to number 9. AH is equal to HG and CJ is equal to JG. AH is equal to HG and CJ is equal to JG. Okay, this right here is a midpoint. We constructed it as a midpoint. Therefore, these two pieces are equal and these two pieces are equal. So that's why I wrote definition of midpoints. And then I can use substitution and say AH equals HG equals GE. CJ equals JG equals GD. Diagonals of a parallelogram are congruent. These pieces are congruent because they're midpoint, because of the midpoint. Therefore, each one of these pieces is congruent to each other. Substitution POE, property of equality. Cool. Now we see that AG is equal to 2 times GE. CG is equal to 2 times GD, segment addition. We just proved that our ratio is sort of 2 to 1 for that mid-segment. Not mid-segment, back it up, median, I'm sorry. We said when we started this discussion that median, the length of the median, the length from the vertex to the centroid is twice the length from the centroid to the midpoint of the side. So we just proved that, and here we have a ratio of 2 to 1. The intersection point of the median divides each median into 2 parts with lengths of a ratio 2 to 1. Therefore, all medians are concurrent at that point. Three medians of a triangle are concurrent at the centroid. I keep drawing this, but it's okay. Or the center of gravity. This point of concurrency divides the length of each median into a ratio of 2 to 1. Okay, 2 to 1. 2 to 1, 2 to 1. The length of the vertex to the centroid is twice the length from the centroid to the midpoint of the side. Okay, let's try a problem. In triangle ABC, the medians are concurrent at F. DF is 4, BF is 16, and AG, this one right here, is AG is 30. So let's find the length of everything. First of all, FC. FC is going to be twice the length of DF. So FC is 8. Let's see, DC. Where's D? Oh, DC is the whole length, so 8 plus 4. AF. AF is right here. So if we have, this is 30, we're going to have 10 and 20. So AF will be 20. BE. BE is the whole length. So if that is 16, that is 8, and our total is 24. FG, right here, we already labeled it as 10. And EF. EF, we already labeled it as 8. Good job. In the figure to the right, triangle ABC, triangle ABC is reflected over AB to create triangle ABD. Points P, E, and F are midpoints of AB, so those are equal. BD, those are equal, and BC, respectively. If AH equals AG, where's AH? If AH equals AG, prove that PH equals GP. PH equals GP. Cool, let's see how we can do that. We have triangles here. Let's see if I can highlight it. Okay, I have two triangles here that it looks like I can make them congruent to each other. Right? We're trying to prove that PH is congruent to PG. So let's see. We have, AH is equal to AG. Because the segments are preserved, we haven't really used this yet because of the reflection, rigid motion. So then we can do angle FAB. The measure of angle FAB is equal to the measure of angle EAB. Same reason, well, sort of same reason. The angles are preserved because of rigid motion. So we've got that. And then we have AH. Yep, we already said that. Oh, I need that middle one. AP is equal to AP because of the reflexive property. So now we have triangle HAP is congruent to triangle GAP because of side angle side. So now we got the end. pH is equal to GP, CPC, Awesome. Oh, and that's it. We're done with the lesson. Good work, guys.